All right, now most books will teach you how to add and subtract fractions next, because it makes sense that addition and subtraction is easier than multiplication and division. Well, actually, in terms of fractions, multiplication is actually easier. And division is actually easier, believe it or not. So what we're going to do now is work on multiplication of fractions, and you'll see how incredibly easy it is. And then we'll do division, and then we'll go on and do the addition and subtraction. You'll find out that none of it's really hard, but it's actually easier to do multiplication than anything else. So let's work on that right now. What if you were to multiply 1/2 times 3/5? All right. So all you do when you multiply fractions, it doesn't matter what these numbers are. It doesn't matter top numbers, bottom numbers. All you do, multiply the top number separately to get the new top number. Multiply these bottom numbers, these are called denominators, to get the new denominator. So 1 times 3 is 3. 2 times 5 is 10, and that's it. You look at your answer and you see if you can simplify it, but there's nothing I can divide into these to simplify it, so I'm done. 3/10. Multiplication of fractions is just that simple. You don't do anything else but this. 4/3 multiplied by 6/5. All you do is multiply the top. 6 times 4 is 24. 3 times 5 is 15. And you always look at it and see, hey, can I simplify this fraction? And in this case, I can, because I know I can divide the top and the bottom by 3. I'll write that reminder to myself. 24 divided by 3 is 8, because 8 times 3 is 24. 15 divided by 3 is 5, because 5 times 3 is 15. So I have 8/5. So what I'm trying to say is when I multiply these fractions, this is the answer, but this is also the answer representing exactly the same amount of stuff. It's just written in slightly simpler terms. Not quite as big of numbers, but it represents the same amount of material. Okay? Well, let's go and do something different a little bit here. Slightly different anyway. 5/12. Let's multiply that by 18/5. All right, now, using the same pattern as before, we could just take 5 times 18 and get the new answer on the top, and do 12 times 5, and that would be 60, and that would give us 60 on the bottom. We would have our answer. We could try to simplify it. That is always correct. You're never going to go wrong by doing that. You can always just multiply the top, multiply the bottom, and there you go. However, it's very important for us to introduce some other ideas now, because when we get in later in algebra, you'll be using them over and over again. Anytime you have these things multiplied like this, if you have sort of like a common term on the top that's also on the bottom, it doesn't matter where it is, because these are all going to be multiplied together anyway. But if you have it on the top and on the bottom like this, then I can simply strike through them and sort of cancel them out. Now really what you're doing, you're not really canceling them. They're not really disappearing. It's just that what's really happening here is, if you think about it, let's do a little bit of an aside here, and you'll see why we're doing this. If we were to do this, it would be 5 times 18 on the top, but then we would be dividing by 12 times 5 on the bottom. So ultimately what we're doing here is we're multiplying by 5 on the top because of this 5, but then we're going to turn around and just divide by 5 again. So we've multiplied by 5 on the top, but then we just divide by 5. So, it's just like taking, what if we take 1 times 2, right? That's going to give us 2. Right? And then we take 2 and then divide it by 2 again, this answer, and divide it by 2 again, and that's just going to give us 1. So the fact that we multiplied by 2 and then we divided by 2 really disappears. We end up with the same number that we started with. If you take 3 and then multiply by 4 and then just turn around and divide by 4, then the 4s really don't do anything. They basically disappear because you've multiplied by it and then you divided by it. Well, that's exactly what we're doing here. We're multiplying by the 5, but then we're dividing by the 5. So in fact, they really kind of disappear. And really, if you want to really be technical about it, they don't really disappear. It's just that they're dividing out. 5 divided by this 5 on the bottom is you're getting a 1 here and a 1 here. So in other words, you can think of it any way you want. You can think of them disappearing because of this cancellation, but you can also think of them as disappearing and leaving a 1 behind because they're dividing out from one another. Now let me also show you something else that we can do in this fraction to simplify it. We could now at this point take 1, because this 5s are gone now, we could take this 1 times the 18 and get a new numerator, 12 times the 1 and get a new denominator, and then we could simplify that. That's also possible. But we can actually simplify more ahead of time here. because this is all multiplied together. Notice that we have 18 and 12. Okay? Can I divide both by something to make it simpler? Well, I can divide this guy by 6. I can divide 6 into 18, and I can divide 6 into 12. So when I divide the 6 into 12, 12 divided by 6 gives me 2. So I scratch that out with a single line and put a 2 there. 18 divided by 6, I put a line and I say 3. So what I have done is totally simplified this fraction. Let me continue on and we'll come back and go over this part a little bit more. All of the big numbers are now gone. We have a 1 times a 3, giving us 3. We have now a 2 left over times a 1, giving us a 2. And this is totally simplified, 3 halves. So I want to make absolutely clear, if you didn't do any of this simplification, 5 times 18 would give you a big number on the top. 12 times 5 would give you a big number, that's 60, that would be on the bottom. But see, then you would have an answer that you would definitely have to simplify again, right? You'd have to divide by top and bottom, and you have to get it down to the simplest terms, which would give you this answer, by the way. All we're doing is we're doing the simplification ahead of time, so we don't have to deal with the big multiplication. We're looking at the 12 and the 18, and we're saying, hey, I can divide both of those by 6. 12 divided by 6 gives me 2. 18 divided by 6 gives me 3. So I mark them out with a single line. Don't scratch it out. Just mark it out and write those numbers down. Okay? And then notice I explained that these are kind of canceling, but it's really the same thing. I have a 5 on the top and a 5 on the bottom. So I can think of it, if I want, as dividing by 5 here. That gives me the 1. Down here, I'm also dividing by 5, giving me the 1. So again, I'm doing whatever I want to the top and the bottom of these fractions as long as I'm consistent. Divide by 6, divide by 6. Divide by 5, divide by 5. When I do that, I get new fractions that are much simpler and that can be readily multiplied. I didn't have to pull out a calculator to do this multiplication. I just get the answer directly. Okay? So what we're going to do is just keep on working a lot of problems here. If this idea is a little foreign to you, don't worry about it, because we're going to do a lot of these things and it will become very clear. What if I had 17/34 multiplied by 3/6? Okay? So again, I could take 17 times 3 and get a numerator. I could take 34 times 6 and get a denominator, but I'm going to have huge numbers, and then I'll have to simplify this huge fraction. Much easier to look and see if I can pre-simplify it. I immediately see a 3 and a 6. I know I can divide top and bottom by 3. 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. Single line, mark the new number there. So now I've already simplified this. Let's see if I can do anything there. You might look at those and say, well, I can't really do anything to 17/34 until you realize 17 times 2 is 34. So I can divide top and bottom by 17. 17 divided by 17 is 1. 34 divided by 17 is 2. So now everything's gone. Only these red numbers are now present. So 1 times 1 gives me 1. 2 times 2 gives me 4. 1/4. So again, I want to stress, you could do the multiplication and the simplification and you'll get this, but see, I'd have to deal with all this multiplication. And then I would have to simplify the answer. If I do a little bit of pre-work, then my answer is going to come more quickly and easily, really. All right, let's go and work a little bit different. Let's look at 12 times 5/6. The number 12 times 5/6. Now, you might look at this and say, well, he hasn't told me how to do this because I've been dealing with fractions, and this is not a fraction. But anytime you see a whole number, anytime, and you're dealing with fractions, you should always rewrite that fraction, rewrite that number as a fraction, 12 over 1. So that's what 12 is, 12 divided by 1, right? And so here I have 5/6. Don't forget, fractions in general are just division. That's what they are. They're a shorthand way of writing division. Way back in the beginning, when I said 6/12, it's part over whole, it's also representing division. 6 divided by 12 gives us 1/2, or 0.5 in your calculator. 12 divided by 1, that's a fraction that gives us 12. Fractions in general are division symbols, basically, is what they are. So here I have 12 over 1 times 5/6. And I'm trying to pre-simplify this. I'm noticing the 12 and the 6 are easy targets. I can divide both of these by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. Now, I can't do anything else with the 5 or anything, so I'm basically done. 2 times 5 gives me 10. 1 times 1 gives us 1. Now, I can circle the answer and say 10 over 1, but don't forget, fractions are just division. So 10 divided by 1 is 10. And that's the answer. So if you take 12 and multiply by 5/6 in your calculator, you'll just get a number 10. That's going to come out the answer. Now let's do one more in this little series here on multiplying fractions. 10 21st multiplied by 14. Same exact deal. I've got a fraction times a number, but just to make it easy on yourself, make it a fraction multiplied by a fraction. And you can visualize it easier, 14 over 1. Now let's try to do some pre-simplification right here. It looks like it's not going to be possible, but on the top I have this 14 and the bottom I have this 21. If you think about that hard enough, you can divide by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Now, there's nothing else I can do as far as pre-simplification. So what I'm going to have is 2 times 10 gives me 20. 3 times 1 gives me 3. So I have 20 over 3. And this again is an improper fraction, 20 over 3, but we're just going to leave them like that for now because really, you know, I know that you've been in math up until now. You've learned about mixed fractions, and you know, in the pre-algebra tutor I actually taught quite a bit about how to convert these back to mixed fractions. But in algebra, you don't worry too much about mixed fractions too much really. If you get a fraction, even if it's improper, you generally just leave it like that. So it's not that important to convert back and forth. So I'm not going to emphasize that too much. If you're confused about how to, if you want to convert back to a mixed fraction where it's like 3 1/3 or something like that, then you could certainly go and review some of the pre-algebra material that'll give you that foundation. And we'll do a little bit later on as well. But certainly in algebra, the focus is not going to be on doing that. If you get an improper fraction, you'll leave it that way. Now, we've covered quite a bit of material when you think about it because we've introduced what is a fraction. We've taught how to simplify fractions, and we've taught you how to multiply fractions. And I promised you that division of fractions is also not hard, and I'm going to live up to that right now. It's actually easier than adding or subtracting them. Let's go ahead and divide fractions. Divide fractions. All right, so let's do one like this. Let's say we have 3/5 divided by 2/3. All right, so we have a fraction and we're dividing it by another fraction. Now, let me show you a different way to write this. Not so much because it's better or because it's proper, just because in your algebra books you'll probably end up seeing it this way eventually, and I don't want you to be confused. This division symbol, the bar with the dots, is what you've really learned up before algebra. But when you get into algebra proper, which is what we're going to study in this course, you don't use that symbol too much because it gets in the way of all your variables and everything else. So if you want to represent division, this is okay, but another way to write it would be like this, and you'll see it's not a big deal. 3/5 divided by 2/3. Now see, it looks a little funny at first until you realize this is just a big division bar, which is like a fraction bar. So you have 3/5 on top, 2/3 on the bottom. Okay? So when you think of it this way, it's kind of nice because in order to do this division, all you have to do is take the first fraction, 3/5, and you change this division into a multiplication. You put a multiplication symbol, you take the bottom fraction, you flip it over, and make it 3/2. And then you do the rest of the problem exactly how we've been doing it just a few minutes ago. So really all, and this is very important, all fraction division simply becomes multiplication. That's all it does. And you already know how to do multiplication because we've just been doing it. So all you do is you take the first fraction, flip the second one over, and multiply them. And that is going to give you the answer to this division problem. So we look at this. We try to pre-simplify. I don't see anything I can divide by, so I'm just going to do the multiplication. 3 times 3 is 9. 5 times 2 is 10. I can't simplify this anymore, so I circle it. 9/10 is the answer. Now, when you're in younger than you are right now, and you learn long division, division of numbers, that can get very tedious and difficult at first. There's a lot of steps, remainders, and all that stuff. With fractions, it's really easy. All you do, take the second one, flip it over, multiply. And that's it. So let's work another one. Let's say we have 3/4 divided by 6/5. Okay? Now, I've introduced this to you guys just to kind of show you what that is, but you don't really need to write it like that. I was just mostly introducing it. You can just do it like this. 3/4, change this division into a multiplication, flip the second fraction over, 5/6. All right. Now I try to pre-simplify. Always get in the habit of doing that. I have a 3 and a 6. 3 divided by 3 is 1. 6 divided by 3 is 2. There's nothing else I can do on top and bottom, so 1 times 5 gives me 5. 4 times 2 gives me 8. 5/8. And that is the answer, 5/8. Okay. Next problem, change colors a little bit here. Let's say I have 2/13 divided by 8/13. Okay, so let's change it into our multiplication. First fraction stays the same, 2/13. Change this to a multiplication symbol. Take the second fraction, flip it over. 13/8. And then I should immediately start looking to see if I can pre-simplify. I see a 13 and a 13. I know I can cancel them. Another way to think about it is I can divide top and bottom by 13. 13 divided by 13 gives me 1. 13 divided by 13 gives me 1. I see a 2 and an 8, so I know I can divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 8 divided by 2 is 4. So I have everything totally simplified. These numbers are gone. 1 times 1 gives me 1. 1 times 4 gives me 4. The answer is 1/4. 1/4. And you would get exactly the same thing by doing 2 times 13 on the top and 13 times 8 on the bottom and simplifying, but 13 times 8 is going to give you a really big number, and then you're going to have to simplify it on top of all of that. So it's a little bit cumbersome. Let's just do a few more and just get our skills just to make sure they're rock solid with this. If I have 21/35 divided by 3/14. When I have division, I always rewrite it. So rewrite the 21/35, change it into multiplication, take the second one, flip it over. 14/3. And I can simplify this. I have 21 and I have a 3. I can divide by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. And I have exactly the same thing going on right up there. I divide the top and the bottom. Now, let's say I don't realize that I can also simplify this. I know that I can simplify this further, right, because I can divide by 7. I can divide by 7 on the top and by 7 on the bottom and simplify this further. But let's say I don't get that. Let's say I don't remember that. So let's go ahead and do it. 7 times 14, you'll do that by hand or in your calculator, and you'll get 98 on the top. On the bottom, 35 times 1/3 is 35. So you're left with this, and then you'll have to look and see if you can simplify that. And if you play around with that long enough, you'll realize that you can simplify it by dividing by 7, right? 98 divided by 7 is 14, and 35 divided by 7 is 5. So the answer is 14/5. So I guess what I'm trying to say is that you try to pre-simplify as much as you can. If you do all of the pre-simplification possible, then the answer that you get is always going to be totally simplified. If you miss one and just go ahead and compute the answer and then simplify the answer, you're going to get exactly the same thing. You're going to get the right answer. It's just that you might have to do some simplification at the end, which is what we did here. All right, now let's go and do another one. Let's do 6 divided by 3/14. 6 divided by 3/14. Okay, so we're going to write this at 6. We're always going to write as 6 over 1. We're going to change this division into a multiplication. We're going to flip this guy over, 14/3. Okay. Next, we're going to simplify 6 and 3. 3 divided by 3 is 1. 6 divided by 3 is 2. We're done with the simplification. 2 times 14 is going to be 28. And on the bottom, 1 times 1 is 1. Don't forget, fractions are just division, so 28 divided by 1 is just 28. So if you were to take this in your calculator and take 6 divided by 3/14, you would just simply get 28. We'll do one more of this problem type, and then we'll work on some more other skills. Let's do 42 divided by 30 divided by 7 over 1, which is just divided by 7, by the way. So we'll just do 42/30 right here, change this into multiplication, and then flip this over to 1/7. Okay. Now let's see, can we do any simplification? But before, we can work with 42 and 7. 7 divided by 7 is 1. 7 divided by 42 is 6. So we're done with that. Multiply the top. 1 times 6 is 6. 30 times 1 is 30. Now look at that. We actually still have some other simplification that we can do. 6 and 30. I know I can divide the top by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. So it's 1/5. And that's the answer, 1/5. Now how did we do that? Why did we not get the fully simplified answer when we did this? It's because we missed something here. We simplified the 7 and the 42 to give us the 6 and the 1, but I should have noticed right here, I have a 6 and a 30 here. So I would have been able to simplify this a little bit more here before doing any multiplication. But like I'm saying, even if you forget to do it, just do the multiplication, simplify your answer, and you're going to be on the right track and get the right answer. So again, we've learned how to multiply fractions. We've learned how to divide them. And you see there's really no difference. You just take that division, flip it over, make it into a multiplication.